Hi everyone and welcome to video number 13 of this series in which we are learning how to model an end plate steel connection, which is this model that you see here. In the previous video we have finished post-processing this first version where we have the bolted connections modeled using coupling, beam, translator, and coupling. In this video, we are going to start creating the second version of this module in which we're going to model the bolts, washers, and nuts using solid elements. Guys, before we start working on this new version, let me show you one thing. I have put in the previous video one additional module to run with this new boundary condition where I'm fixing the degrees of freedom 2, 4, and 6 of this node. And the result is shown here. Let me animate this result. If we press F2, we get this view, and then you see that this beam moves in the negative Z direction. It doesn't have any torsional movement. So we don't have a rotation about the x-axis because of that boundary condition. We don't have a displacement in the y-axis as well because of that boundary condition. And anyways, it behaves a little different, right? We yet have this instability occurring here, and we can extract the moment versus rotation curve. And then I have put it here in this Excel spreadsheet. And then you see that I have generated this green curve. This green curve is very similar to the previous one, the blue one. The only difference is when we have this instability occurring. So we have the instability occurring here for this new model a little later, okay? But there is not so much difference here in this region. So again, we are having some differences here between the experimental data and our simulation. And the reason for that is because of the assumptions and simplifications that we have introduced in our model. I guess that the main reason is because of the material modeling that we have used, the perfectly plastic material modeling that we have used. Okay, maybe if we had a more accurate plastic strain versus stress experimental data related to the materials that we have in this model, maybe we would have a better approximation here, a better representation. But I guess this is good enough. The last thing that I wanted to show, let me go back here to this model. This is the first model without that new boundary condition. Notice that when we have this instability occurring, you see how we have this deformation occurring here, right? In the beam flange and also in the beam web. If I go back to this document that has experimental data and scroll down, you see that we have these images here. Notice what happens in this image. Notice this buckling here and also on the beam web. It is very similar to what we are having here, right? So it's interesting that in this model we are able to capture this instability that occurs in the beam. It looks very similar, right? And also if you look at how this deforms in here or in this image, we or even in this image here, if we press F2, 3, if we press F3, you see that we have something very similar happening here as well, right? We can go to tools, settings, drawing, model geometries, shell solid, draw thick shells, and here we have this kind of deformation occurring, which is similar to what we have here, this gap opening in this region. And anyways, it's very similar. So it's interesting. All right, so let's then start working on the second model. So first of all, in the second model, I wanted to have this new boundary condition that we have created, this one. I want to eliminate it. I don't want to have it. I'm going to delete. And let's go to File, Save As, and let's give it a different name. So this is end plate solid bolt washer nut. Save. And let me check one thing here. Okay. First of all, let's change here to Abaqus deck so that you have the same database as I have. In the yellow buttons, you should have everything that I have activated here. And also here, let's deactivate visualization of spots and hot points. In the draw mode, select property ID. And in the database, deactivate the visualization of curve, but you should have activated visualization of point. Actually, activate visualization of curve because we are going to create curves here. Okay, just deactivate visualization of measure so that we don't have that measure showing up here. And guys, we have many points in this model, right? Let's delete all these points because we're going to create some new ones, and I don't want these existing points to confuse us. So double click on point, and then from this list, select one item and Control A to select everything from this list, right click and delete. Okay. And also curves. Let's delete all curves. Double click on curve, select one item here, Control A, and right click and delete. Okay. So let's then work on this area. I'm going to delete all these couplings, all these beam elements, and all the translators that we have here. Let's start with the couplings. Double click on constraint so that we have constraint selection mode. Create a box selection to select all these couplings. Be sure that you're not selecting these other couplings here. So zoom in here and create this box selection. And from this list, or even you can right click here, for example, and then delete. You can have this checked, delete released nodes. So it's going to delete any nodes that are not connected to anything. And now let's delete the beam elements. So from the elements item expanded, double click on beam, create a box selection, right click and delete, and click on OK. And then now the translators. So double click on connector, create a box selection, right click, delete, and OK. We will need to create a new translators again, but it's a good idea to create it from scratch. And in this case, we're going to create only one bolted connection, and we're going to copy these to the other holes. So we're going to be more practical in this situation. Now, just to guarantee that we don't have any entity unused floating here, let's apply a compress function. So search for compress. And then in here, activate details, all decks, uncheck this box and check it again to be sure that you have everything checked. And then we are going to have 53 nodes deleted. Looks like we had some nodes here that are floating and that are unused. Looks like we have some sets related to the couplings that we had here. Anyways, let's just clean this model, click on OK. Now it's all entities unused were deleted. Now let's create these bolts here, for example. Guys, there are many ways to do this. Usually, we don't create the CAD of the boat in this software. Usually, we receive this CAD ready for us to use. Actually, depending on the company that you work, just as an example, when I worked at Stellantis, I worked in a team that was not responsible for meshing. In Stellantis or in any big company, you have specific teams for specific activities. So there is like a team that is only responsible for CAD, and there is a team that is only responsible for meshing. And there is a team that is only responsible for creating modules and running and debugging and post-processing. And I was part of this team, for example. So I would receive the meshes ready, at least in Stellantis. In other companies, I needed to also create the mesh from scratch and create the model. So maybe in smaller companies, you will need to do the whole procedure. So my point here is that maybe depending on the job that you get, you will not need to mesh complex parts because there's going to be a team responsible for that. So you're going to receive the meshes ready, or you're going to receive a CAD and then you need to send this CAD to a specific team so that they can mesh it, and then they are going to return you the mesh, and then you're going to input this mesh in the model. But in here we're going to do something different. We're going to create the geometry, we are going to mesh it, and we are going to do everything. Even though this is not something that is normal. We're going to do everything for one specific reason. Because the tools that we end up using to create the CAD are tools that are also important for many other things here not related to CAD. So that's important to know how to create simple CAD here in ANSA, because you're going to end up using these skills even though you're not going to create CAD from scratch in your own experience. Okay? And with respect to mesh, I thought about downloading a CAD in GrabCAD, for example, of a bolt, nut, and washer. But usually the geometry of these entities is not so simple. For example, the head of the bolt can have a complex geometry. The bolt can come with a thread. And then we would need to treat this geometry using some tools here in ANSA to simplify this geometry so that the mesh is going to look good. Maybe we would have to use advanced tools here related to meshing, such as batch mesh. And this is not a tutorial that I want to spend so much time teaching about how to mesh a part, because I have a specific course about it, the ANSA meshing course. So my point is, if your job requires you to also mesh complex parts, then I suggest you to do this course about ANSA meshing techniques for advanced meshes. So for example, in there you're going to learn how to mesh plastic parts, which is the most complicated kind of mesh that you can perform. But if in your job you don't need to create complex meshes, just simple meshes, and you're going to receive the complex meshes ready for you to work, then you just need to know these tools that I'm teaching in this tutorial, which are simple tools related to meshing. Okay. All right. So in here we're going to create a simplified bolt so that we don't have to use any complex tools related to meshing, and we're going to create this CAD from scratch. Let's do this. Let's go to the classic topo module. This is the module that we create CAD entities, as you know. And then first of all, I want to create a point on the COG of this hole. Just follow what I'm going to do, and eventually you're going to understand why I did it. To create a point on the COG of this hole, we are going to find the point group, this tool on COG, left click and hold, and then select this third option, circle. Now we need to select here 3 nodes that is going to define this circle. So to define a circle, we need to click on 3 points. For example, this one, and this one. You can select any nodes that are part of this circle, middle mouse button, and then we have these points created on the center of this circle, right? Now, the first thing that I want to draw is the washer. I need to displace these points in the negative x direction, in this direction, because this is going to be the center of the circle that I'm going to use to create the washer. And this should be in the x position where we have contact occurring between the washer and the end plate. So I need to displace this point 10 millimeters in the negative x direction, because half of the thickness of this end plate is 10 millimeters. So let's do this. Let's use the transform tool that you can find here, or maybe here. Okay, transform and move. I want to select entities because a point is a kind of entity. Zoom in, select this point, middle mouse button, and then move, translate, tab, negative x direction, 10. Guys, I'm going to start being a little faster here, okay? Because these are tools that I have already used before. Plus, finish. Now we have the point here. Ask to deactivate the tool. Now, I want to create a circle here in the YZ plane. To create a circle, we have inside the curves group, the create tool, this tool here, and then circle, and then 2D mode, and then I need to select a plane. But I firstly need to create this plane, right? This YZ plane that passes through this point. So let's close this. And then there is a tool here that we can create planes. It's here in the auxiliaries, working plane, left click and hold, new. And then in this part of the screen, we can select the mode, so single point mode, normal plane. We can select here YZ global plane. So if I select this point here, this one, and the software is going to create one plane that is parallel to the YZ plane and that passes through this point, because we have this option selected here. Middle mouse button. Now we need to assign a part. Could be in auxiliary entities, double click. And you see that this plane is not visible. So to have it visible in the database, activate working plane. This option, activate it, and there we have it. You see that this plane is green, which means that it is active. If we double click here in working plane, here we have the working plane, and it's active. You see it's green. If we want to activate another plane, we need to right click and say set active, but that's not what I want. I want to have this active, and then I'm going to use again create curves, circle, 2D mode, select plane, and zoom in. And you see that this plane is already selected because it was active. So the software automatically selects this plane. But if in your case it's not selected, you can simply select it. And then now we are sketching on this plane. By the way, we are going to create a curve. So in here we can select in parts, ask always. And then I'm going to position the center of the circle here, left click, and then move the mouse like this in the horizontal direction, getting this snap of the horizontal direction, because again, we're going to create a hot point where we click here, and I want this hot point to be positioned in the horizontal direction. And I want this diameter here to be equal to, well, if the bolt diameter is equal to 20 millimeters, and a bolt is going to pass through this hole. Imagine that I'm creating the hole of the washer. Then I want this hole to be a little larger than the diameter of the bolt. So the radius here could be, for example, 11, or yeah, could be 11, so that the diameter is going to be 22. So to define this radius, press space and then type 11 and press enter. And then now select auxiliary entities as the part to assign this new circle. Now let's create the outer diameter of the washer. So again, click here, position the mouse here, and I guess that a good outer diameter, maybe, I'm just assigning arbitrary values here, but obviously that in a real work, you should look at a catalog of the washer that you want to put here, and then you should obtain this information from this catalog. But in here, we're just going to create something approximated, just as an exercise. I guess a good diameter here could be 17, space 17 as actually the radius. Press enter. Auxiliary entities. And I guess this looks good. Now we can rotate this view using the control and left mouse button. Now there is one thing here that we need to do. I wanted to create a surface, but to create this surface, I can't have these inner and outer circles. The new surface tool is not going to work properly. So what we need to do here is to use the line tool and close. And well, we don't have, we have this snap here of 0.5. Find this snap of 0.5 here. Left click and go to this other curve, and also find this snap of 0.5. And then middle mouse button to conclude and put in auxiliary entities. Now we have this new line, and I need to do the same thing here. From here to here, middle mouse button, auxiliary entities. I should have this like this to create the faces. Now close this tool, and guys, let's do one thing here. Let's use the not function, PID selection mode, create a box selection like this using the left mouse button to hide all these entities. Just be careful to not hide the curves. And then now we have only these visible, and let's lock this view by clicking here, so that when we click in show all, it's not going to show everything. Press ESC to deactivate any tool. Now we don't need anymore the visualization of this working plane, so in here deactivate this box. And now let's create the faces. So use this tool here inside faces group, new, it's a planar face. Let's use this algorithm. And now well, we need to do one additional thing here that I forgot. So close this. We need to split this curve. So if I double click on curve, you see that this curve is like this. I want to split this curve in here, and also this one in here. To do this, we are going to use the hot points group. There is a project tool. Select this one. And I want to project this hot point that is part of this vertical line on this curve. And I want to project this hot point on this curve. And I also want to project this hot point on this curve and this one on this curve. Now, if I double click on curve, you see that we have this split in two. Okay. Now we can use the new faces, planar. And in the parts, we can ask always. And in property, we can also ask always. And then select this curve, this one, this one, this one, this one, and this one. Middle mouse button. We can put it in auxiliary entities for now. And for property, we can create a new property, right click, shell, and this is going to be a temporary property, temp. So select temp here, click on OK, and double click on this property, and let's accept, click on OK. We are going to delete this property later. You're going to understand why. Okay. Now we have half of this face created. We need to create the other half. So select this curve, this one, this one, this one, this one, and this one. Middle mouse button, this part, this temporary property, click on OK. Now let's deactivate visualization of curves for me to show you one thing. Uncheck this box. And now I have this circle here. You see that the resolution is not so good, right? We can control the resolution of ANSA in tools, settings, translators, resolution, tolerances, and everything. You see that tolerance mode is middle. I don't really usually do this because there is another way to do this. I usually keep the resolution small. You can increase the resolution by selecting extra fine here, but you would need to reopen ANSA and everything. But I don't usually do this. I like to have the tolerance small so that the computational cost is lesser. And if I need to increase the tolerance, the visualization, it's not tolerance, it's anyways, the visualization refinement, I don't know. There is this tool here in the auxiliaries group, fine, and then we can left click in a specific cone, and then you see that we are increasing this tolerance like this, right? So that it's looking more like a circle. Or we could go to the classic mesh module, and then we can use the length function to define the distance between these perimeter points. Left click here, select everything, middle mouse button, and then we can define this as, I don't know, if I select 1 here and press enter, you see that the resolution is very good, right? But then I'm not going to create elements with length equals 1. I want to create elements maybe with length, let me select everything, middle mouse button, maybe with length equals 3. Yeah, I guess this is going to be a good element, length, for the washer. So let's define it as 3. Let me go back to, well, let me go back to the classic topo module. And then in here, you see that I have a double cone, yellow cone, right? So this means that this cone is part of two faces, this face and this face. If in your case, you don't have a yellow cone, if you have a red cone here, then use this function here, topo, select everything, middle mouse button. And then you're going to be sure that you have this pasted together, as I have explained in previous videos. Now I'm going to do some stuff without explaining, because then the videos are going to be too long. I need to be practical now. Let's go to the classic mesh module. And now I want to create the mesh on this face, and you're going to understand why. To create this mesh, first of all, let's go to the mesh parameters. And then in here, I want to have, could be mixed. The target length is going to be 3 for this one. And could be first order, click on OK. In quality criteria, we're not going to define anything because this is going to be a pretty simple mesh, so we don't need to use any quality criteria for this one. Now, in the shell mesh group, actually in the mesh generation group, I'm going to search for an algorithm that is here in more options, in my case, named map. So try to find this meshing method named map. Maybe it's in this part, or maybe it's in here. Or you can search it in here. Map, left click and hold, and then select everything here, and middle mouse button. This meshing algorithm tries to generate a very organized, a structured mesh in a specific phase. But in this case, you see that it's not looking good, because for this to work, we need to have the same number of divisions on opposite cones. So let me explain what this means. If I use here in the perimeters group this function number plus minus, I can control the number of divisions in each cone by left clicking or right clicking. If I left click, I increase, and if I right click, I decrease. But before we do anything, in this part of the screen, in mesh, you should select remesh macros, so that whenever we perform any kind of modification, the mesh is going to be redone in the specific macro. Macro is just a phase. So for example, you see that in here I have 6 divisions, right? In here I have 9. I should have the number of divisions here equal to the number of divisions here. So maybe I'm going to increase the number of divisions here to 7, and in here I'm going to decrease. Oh, and to increase, you should left mouse button with this number plus minus function, and I'm going to decrease the number of divisions here to 7 as well. And to decrease, we should use the right mouse button once and twice. Do the same thing here. Increase to 7, left mouse button, and decrease to 7. Now you see that this mesh is looking good, right? Do the same thing here. Left mouse button to increase to 7, right mouse button to decrease to 7. Left mouse button, right mouse button twice. In here I have 2 divisions, and in here as well I have 2 divisions. So the map algorithm is working well now, creating a very organized mesh, which is what I want. And if we look at this mesh, looks like the aspect ratio is good enough. The quality of the elements are good enough. We don't even need to use a quality criteria method. Actually, if you're working officially in a company, you're going to use quality criteria every time. But in here, let's not use it, to be more practical, because we can see that the quality is pretty good. Okay, now we have here shell elements. Why did we create shell elements? Because we want solid elements, right? There are 2 ways to create solid elements. We can create an unstructured mesh, which is going to be composed of tetrahedrons, first order or second order. And this is usually used for complex geometries, complex domains. In this case, we have a simple domain. So we can use a structured mesh. So we have unstructured mesh, tetrahedrons, and structured mesh, in which we are going to have a mesh composed of only hexahedrons. We also have hexa first order and hexa second order with mid-side nodes. But hexa first order is good enough. We don't need to use hexa second order elements. The computational cost is too high. It's not that it's not a good element. It's a pretty good element, but it's not worth it. The computational cost is too high. First order hexa is good enough. So we're going to use then a structured mesh algorithm to produce only hexas. To do this, let's go to this new module, volume mesh. Maybe you don't have this button available, depending on your ANSA version. Maybe first of all you should select classic mesh, and then you're going to have a new button showing up here, and then you can select volume mesh. Or anyways, guys, if you don't find it, just look around in this region and eventually you're going to find it. We need to use these tools here, and there are many ways to create, you see, in here we have this group, unstructured mesh. We're going to use it later for the bolt. And here we have structured mesh. These are the tools that we are going to use. We have many tools here, but the one that I want to use is this one, extrude. because we're going to extrude this face to create the solids. Left click in extrude. And first of all, let's set up here a part. Let's ask always, and property also ask always. First of all, we need to select a source. The source is going to be these shell elements that we have created. So I'm going to select here by shells. And then I'm going to create a box selection to select all these shells. And then we can go to next by clicking here or using the middle mouse button. Now the target, well, we are not going to have a target, so none. Middle mouse button. Now the rule, you see that we have many options here. In this case, we're going to offset. And let me see if it's, well, he's showing that he's going to do this offset in this direction, but I want this offset to be in the opposite direction. So I'm going to select inverted here. Okay, you should do this only if you had that other direction. If you have this direction already, you should just select default here. Okay, I want it to be in the negative x direction. Next. And then we can select a distance. Well, I guess that's the thickness of a washer is usually 3 millimeters. It's going to depend on the washer. Let's just say that it's going to be 3. Okay, and the number of divisions that we want to have here is maybe only 1. Preview. You see that I'm not being able to see it. And the reason for that is because in these pink buttons, I don't have this activated. So if I activate it, I can see solid entities. So if in your case you don't have it activated, you should activate this option here. Okay. Now you see that we have these solid elements being generated, right? Notice that if I put here 2 and preview, I'm going to have 2 layers. I guess it's not bad, you know, but we can select 1 and it's going to be good enough. Okay. Now we can click on finish. And now we need to select a part to assign this washer. I need to create a new part. I'm going to left click here in model browser so that it becomes a window like this. Right click, new part. The name is going to be washer. I don't know what happened here. Double click on washer. And now it's asking the property that we want to assign this new solid element. We have this property here that was created automatically. I don't want to use it because I'm not sure if you also have it. So right click, new solid section. And then I'm going to say that this is washer. And I'm going to also use this for the net. So let's put underline net. For the bolt, we're going to create a different one because the bolt is going to have a different material property, as you're going to see. I don't know what happened here. I guess some visualization bug. I hope this returns to normality later. You see that we need to select here in this, the name of this property is solid section. We need to select a material. I'm going to use the question mark to open a list of materials. We have some default materials created here because of the faces we have created. We're going to delete it later. But right now, I want, where is the bolt material? We lost the bolt material, unfortunately, in the compress function. I should have not deleted this material. We're going to create later very fast. I'm going to select this one with ID 3. Which is a default material that was created. Double click on it. And then I'm going to select this and press F2 to modify it. And let's name this as standard steel. I'm going to accept these material properties because these are standard steel material properties. Here we have a density, there is normal for a steel, Young's modulus and Poisson's ratio, and we don't have plasticity defined. So this is just a linearly elastic isotropic material. Click on OK. And here we have the type. Remember that in Abaqus, solid elements have this symbol or nomenclature C3D. 3D means that this is a three-dimensional element. And then we have this underline here because in here we would have the number of nodes. In this case, for the hexahedron, we have 8 nodes. So we would have C3D8. And then usually for hexahedrons, I like to use incompatible modes formulation. So I'm going to choose I here. But we also have very simple reduced integration formulation. But I prefer this formulation here, which is a pretty good one. We have learned about this formulation in details in the course. We have used it before, so I'm not going to explain in details about it. Click on OK. And then the nomenclature of this element is going to end up being C3D8I. This is the total nomenclature. Now we can select this new property that we have created, double click. And now we have this, we can close this. Now we have these solid elements created using this property and this material. Okay. We can activate the visualization of nodes by checking this box of node and zoom in. And then you see that we have only the corner nodes. So this is a first order hexahedron element. We don't have the mid-side nodes here. And also these the sides of the elements are straight. You see? It's not curved. Let me deactivate visualization of nodes. Let me see here, 41 minutes. Okay. Now, guys, we don't need anymore the shell elements that we have used to create these solid elements. Notice here in this part of the screen that we have visible 56 shell elements and all are quad elements, and we have this new item volume where we have 56 hexahedrons out of 56. So we have only hexes. So what I want to do here is I want to delete all these shell elements that we have created because we don't need it anymore. So right click here in total shell elements, show only, use the delete function, select everything, mise mouse button, and click on OK. Now it's deleted. Now if I click on show all, it's going to show only the solid elements because we have this lock view activated. And the washer is ready. Now we can go to the next item. And by the way, guys, let me unlock this view and click on show all. Here we have the washer. And if I activate the visualization of thickness, quality criteria, presentation parameters, draw shell as solid, apply OK, you're gonna see that this back surface of the washer is already aligned with this face of the end plate because we have positioned this point to create this circle in the correct position. You see, we don't have any kind of interference. It's just facing it, and it's important to guarantee that so that we don't have issues with contact. Okay. Because if we have an initial penetration here, we are going to have issues, convergence issues related to contact. All right. So let's start modeling the bolt in a simple manner. For the bolt, let's delete now this point. We don't need it anymore. Double click on point, select this point on this list, right click and delete. Okay. Now let's go to the classic topo module. I'm going to create again a point on COG of circle, zoom in, and I want to create one point on the COG of this circle. Select 3 nodes on this perimeter, middle mouse button, and here we have it, right? Let me deactivate the visualization of the thickness of the shell elements here in quality criteria, presentation parameters. Deactivate this option, apply, and OK. Now we need to create a plane passing through this point and parallel to the YZ plane. So in the auxiliaries, working plane, new, YZ, select this point, middle mouse button, auxiliary entities part, create curve, 2D mode, select plane. Let's have the plane visualization active here, checking this box. You see that we have this plane selected already because it was the last that I have created. So if you don't have, you just need to select it. And then now we see normal to it, deactivate visualization of working plane. And also deactivate the visualization of FE mode. And also the visualization of geometry. No, maybe this is not a good idea. Deactivate the activate visualization of geometry again, because I want to see this point, which is a geometry entity. But deactivate visualization of macros, this one, so that we don't see faces. Macros is the same as faces. Okay, now circle. And then guys, first of all, I need to create a circle that is going to be the diameter of the bolt. Left click here, and in here, in parts, select as always, left click here, position the mouse in the horizontal direction, space 10, press enter, and then could be in auxiliary entities, double click, because these are just auxiliary entities that we are going to use to create the bolt. Later we create a bolt part for the bolt itself. To see the curve, check this box curves. And well, we have other curves here, so let's do one thing here. Let me rotate. I don't want this to confuse us, so I'm going to just double click on curve, and then you see that we have all these curves here, right? I'm going to select everything from this list, and I'm going to deselect this curve, right click and deselect, and also this one, right click and deselect. Okay, and I'm going to delete all the other curves, delete, because I don't need anymore. I just need this new one that I have created. Okay, now again, create curve, 2D mode, select plane. Let's have visible working plane, and then select this plane here. Deactivate visualization of working plane. And then now I want to create the outer diameter of the head of the bolt. Left click here, and the outer diameter of the head of the bolt could be a little smaller than the diameter of the washer. This is usually the case. So maybe 15.5 could be the radius. So position the mouse like here in this horizontal line, space, and type 15.5, press enter, auxiliary entities. Okay, there we have it. Now again, we need to create some, let me think here. We need to create a line connecting from here to here. Let me deactivate visualization of solid entity, so deactivate this option. Now a line from here to here, oh sorry, from here to here, middle mouse button, auxiliary entities, and from here to here, middle mouse button, auxiliary entities. Now let's use the project tool, this hot point on this curve, this hot point on this curve, this one on this curve, and this one on this curve. Okay, now we can start creating. Let's do one thing here. Click on show all, activate macros visualization, and also visualization of FEA entities and volume mesh. And right click on curve, show only, classic topo module, new, planar. And then in here in part, ask always, property, ask always, planar, and then select these, and these, and these. We're going to do something similar to what we have done for the washer, auxiliary entities, and this temporary property. Okay. And then these one, and this one, and this one. There's a mouse button, auxiliary entities, temp, and click on OK. Now, deactivate visualization of curve, and that's what we have. This procedure was very similar to the washer, but now the rest of the procedure is going to be different. I want to create the bolt head, so I need to extrude this outer red cone. I'm going to create a new face in the faces group, classic topo module. I'm going to use the extrude function. Actually, it's in the surfaces group. Extrude, left click and hold, and then select extrude. And then extrusion profile, it's going to be cons. So we have here selected cons. And then select this cone, this one, and this one. Middle mouse button, and now we need to select a direction. Let's select it by a vector, and I want this extrude to be in the negative x direction, so -1 here in the x, and the distance could be, I don't know, the thickness of a bolt head, I don't know, maybe let's try with 8. Let's see if it's going to look good. Press OK. And you see that the direction is not correct. So cancel, because I have this 1 here. So put 0 here. It should be -1, 0, 0. Middle mouse button. Oh God. Again, it didn't work. Extrude. To select all these curves, use the loop selection mode. There we have. Middle mouse button, -1, 0, 0, 8. Middle mouse button, and click on OK. And put it in the temporary property and auxiliary entities. Oh, it's creating one by one. So temporary, auxiliary entities, temporary, auxiliary entities, and the last one, temp, auxiliary entities. There we have it. You see, it's not practical at all to create CAD entities here in ANSA. But these tools are important, guys. We use it in other scenarios as well. So let's create a new face, new planar, loop selection mode. Select this loop. In part and property, select ask always, middle mouse button, auxiliary entities, and temporary property. Click on OK. Close. And this is the bolt head. I guess we could have increased a little the thickness of this bolt head, right? If you compare with these bolts that we have here, you see the thickness is a little larger. Let me see if I can move these, only these. No, it's not going to allow me. Let me try one thing here. You don't need to do what I'm going to do now. We would need to create faces here. I guess I'm going to simply accept. Oh, you see that I have a red cone here, right? I need to paste these together. So I'm going to use topo tool, create a box selection, middle mouse button. Now it's pasted together. Let me try to move these again. Because I need to do this. It's just a test. Okay, it doesn't work. Oh, that's why it's not. I need to paste these together again. Okay, well, we can increase this thickness, but it's not going to be so practical. So instead of, I'm going to increase the thickness of the bolt head later, not now. I'm going to do this modification directly on the mesh, which is something interesting to learn. Okay. Or we could even do this in here. We just need to undo and then extrude this face again with a larger thickness. If you'd like to do this in this manner, you can also do this. But I'm not going to do this because it's the same tool. So you're not going to learn anything new. All right, now we need to extrude this to create the bolt trunk. Let's see how much we need to extrude it. So click on show all. And well, I need to extrude this in a way that it's going to reach this other side and pass through the nut. Imagine that on this side, we could have another washer, but to facilitate a little our life, I'm going to have only the nut. Okay, to facilitate in a way that we are going to have to define less contacts. But the difficulty, it's just going to give more work, but not so much difficulty in convergence. So let's just create a nut here. And for the nut, let's suppose that the thickness of this nut is going to be equal to, I don't know, 10. If the thickness of the nut is 10, and here we have 10, so let's take a screenshot to show the calculations that we need to do here. Let me get the pen. Okay, so this extrude that we are going to perform is going to start here, right? We have this thickness here, which is 3. And then we have this distance here until here, which is 20, which is the thickness of this plate. And then again, 20 here, right? And then we are going to have the nut. Let's say that the nut is going to have a thickness equals 10. So the bolt should have at least a length equals 53. But I wanted the bolt to pass the nut a little. So maybe 60 millimeters is a good option. Okay, 53 plus 7. 60 millimeters. So let me deactivate visualization of these and these, and no, this one is not a good idea. Yeah, it could be like this. And now let me rotate like this. I'm going to hide, using this function, I'm going to hide in property selection mode, hide the end plate. And then I'm going to select classic topo module, extrude, loop selection mode. This is the giratrice, middle mouse button. The direction now is the positive X direction, 60 millimeters. Press enter, a middle mouse button, and click on OK. Select the temporary property, auxiliary entities, close. Oh God, it's creating one by one. So auxiliary entities and temp, auxiliary entities and temp, and again. One of these faces were assigned to a different property, this one with a different color. So let me use the setPID function, select this face, middlemost button, and I want to assign this property. So select this other face, which is the temp property, middlemost button. Okay. Yeah, the thickness of this bolt head is looking really weird, right? But that's okay. We're going to modify it later. Now we need to close here, to close this volume, right? I need to create a closed volume. So new face planar, loop selection mode, selection this, middlemost button, auxiliaries, temp. Okay. Close. And here we have the bolt. Now we need to mesh it. And it's going to be pretty easy to mesh it because this geometry is simple. Let me close this. I'm going to use the not function. Let me see here. 1 hour. Oh my god. Let's finish this mesh and then we can finish this video. PID selection mode. Select the bolt middlemost button. We should have visible these and these to be able to see shell and solid mesh. Now we are going to create an unstructured mesh. That is, we're going to create tetrahedrons. The procedure to do this is, firstly, we need to create shell elements in the outer surface of this solid. And then with these shell elements, we need to create a volume. And then with this volume, we need to create the tetrahedrons. Let's do this. So first of all, let's go to the classic mesh module to create the shell element. Second of all, we need to define the length of these shell elements. So in the mesh parameters, maybe we can try 5 millimeters. And in here, instead of mixed, we are going to select tria or orthotria. The difference between tria and orthotria is that tria is just triangles, and orthotria is like a quadrilateral element split in two. So it's a more organized tria mesh. It's possible to use it when we have simple geometries just like this one. So that's why I'm going to choose orthotria. Click on OK. Now we should use the length tool to define the distance between the perimeter points on the cones. Length. Create a box selection. Middlemost button. Define it as 5. Click on OK. Close. Now we need to create this surface mesh, the shell surface mesh that we're going to end up deleting later because this is just to create the solid element. So to create it, let's use mesh generation, best, left click and hold, and select, create a box selection like this, middlemost button, and here we have the element created. You see that this is an orthotria. It's like a quadrilateral element, but it's split in two. It's a more organized mesh. Well, this is looking pretty good. What we can try to improve is just the mesh on these circular parts. There is a specific algorithm to do this. In mesh generation, maybe not here, a shell mesh. We have this specific tool here. Let me see. Oh yeah, it's in the mesh generation circular. Left click in here. We can accept default, select this, and middlemost button. And then you see that the mesh gets more organized. Click on finish. It's a specific algorithm for circular parts. You see, much more organized. Finish. Press ask. And this meshing is looking good, but there is one thing that I forgot here, guys. I'm sorry about it. In the mesh parameters, I should have selected second order because I want to create second order tetrahedrons. Because first order tetrahedrons is not good. It has constant strain inside the volume, as we know. So select second order, press on OK. And then I need to go to best again here, left click and hold and regenerate. Select everything, middle mouse button. And now if we zoom in, you see that we have the mid-side nodes and we have this curvature on the sides of the elements. So we are going to have the domain better represented because we have a circular boundary here. If we activate visualization of nodes, you see that we have the mid-side nodes. If you do this for the previous elements, you're going to see that we didn't have the mid-side nodes. Again, let's use the circular here on this face, middle mouse button again, and then here, middle mouse button, and again, deactivate visualization of nodes. And this mesh is looking pretty good. Guys, oh, sorry. Just 1 second. Let me close my door. All right. Now, if we'd like to increase this thickness by modifying the mesh directly, we can do this, and it's pretty easy to do this. Let me firstly try to use the move tool. You don't need to follow this. I'm going to just test if now that we have the mesh, it's going to work. Well, no, it doesn't work. Let me cancel, and now it's not pasted together. Let me just use the undo function. Well, we would need to release this shell element from the underlying faces so that it's going to work. Maybe it's going to be a little confusing, but this is something that is very important. So I'm going to show to you. I need to release this mesh from this underlying face because now it's attached to this face. So for example, if I deactivate visualization of macros or faces, it's going to hide the mesh as well. To do this, we can go to volume mesh module and use the release tool. Left click here. And then in these options, let me see if I have anything. So let's see this option here. Disconnect from neighboring geometry. We can activate these. And we have these delete faces and volumes. Well, we can delete these faces. We will not use it anymore. So we can delete faces and volumes. And that's it. Create a box selection, middle mouse button. And that's all. Now, if I deactivate visualization of faces, we have this visible yet. We don't have any more of those faces. Okay. Now, if I use the move tool here, left click and hold, move. We can move, could be entities or nodes. And let's use the feature angle selection mode. Select these elements, middle mouse button, moving the X direction. So define it as 1. And let's move 1 millimeter plus. Oh, sorry, in the negative X direction, minus. Let me just do one thing, cancel. Let's go here and undo this move. And again, move and select these, middle mouse button. And then in these options, let's see, keep connected with non-moved. In here, select yes. Yep. Now I want to move in the negative X direction by 1 millimeter. So click on plus, and now it's working. We can increase a little more, plus. Now we have a total of 10. Maybe 11 is looking good, right? But we need to remesh this part here. Let's click on finish. And now I want to reconstruct the mesh on this lateral because it's not looking good, and only here. So I'm going to go back to the classic mesh module, and there is this function here inside mesh generation, actually inside shell mesh, named improve. If you don't find it here, maybe you're going to find it here. Improve, and then feature area, select this lateral face, 40 degrees here, middle mouse button, again, and again. Close. Ooh, I don't like it because of what happened here. Let me try to reconstruct. Shell mesh, reconstruct, left click and hold, select. Let me see these options here. Fix quality, no, min length, target. Select this lateral face, middle mouse button, and again. All right, now it's looking better. Yep, it's looking much better. We can accept. Close. Yep, now it's looking better, this bolt. So guys, we have a shell element in the outer surface of this solid. The next step is to define a volume using these outer surfaces. You see, we have a closed volume here, so we can define a new entity here in ANSA named volume. So go to volume mesh. And then in volumes group, we have this function here, define. And then in here for part, we can go to ask always, and in property, ask always. And then instead of whole database, we're going to select visible to work only on visible and click on OK. This software recognizes that there is this closed volume, and then it creates a volume with this shape. Now it's asking the property that we want to assign this volume. I'm going to create a new property, solid section property, and then I'm going to name it as bolt. And then the material, we will need to create this material. Let me use the question mark to see a list. And I have some default materials here. I'm going to get this one, the one with ID 4. But if you don't have these default materials, just right click and new, and then create it. I'm going to use this one, double click. And then I'm going to press F2. I'm going to rename it as bolt material. And we need to define plasticity of the bolt later. Click on OK. We're going to work on this material later. In the formulation, we are going to use, in this case, it's a C3D, but it's going to be tetrahedrons, so it has 10 nodes. So it's going to be C3D 10. And we don't need to use reduced integration or anything like that. We can just use the normal formulation, which is a pretty good one, as we know. Click on OK. Select this new property. Auxiliary, let's create a new part. Rename it as bolt. Double click on it. And now we have this new volume. And notice that we had already this other volume that was created automatically for the washer. Okay, but you see that we have this status as unmeshed. So we just have this volume, but there is nothing inside. There is no elements inside yet. To mesh this new volume, let me close this. To mesh this new volume in the unstructured mesh group, volume mesh module, we have these algorithms here to generate this mesh. I use Tetra FEM because it's an algorithm to create tetrahedrons for a module that is going to be built for FEA. Left click here, and then we can select a volume for this. I'm going to select this volume. Guys, if you're not able to select it, it's because in the database, you see that we have this new item named volume. You should have it activated so that you have it visible. Left click on this volume, and then middle mouse button. And now the tetrahedrons were created inside. Notice, if I undo this operation by clicking here, undo this operation, notice in this part of the screen, we have only shell elements here, and all shell elements are trias, 496. and we have one volume unmeshed. Now, when I use tetra FEM, select this volume, mesomorph button, close. Now I have volume, tetrahedrons, and also the shell mesh. Right, let me lock this view, clicking here. Let me use the node function, entity selection mode, get a view like this, use the left mouse button to create a cut, and then you see that we have these solid elements inside. Now, if we activate the visualization of nodes by checking this box, zoom in, you see that for these solid elements, we have the mid-side nodes. So this is a second order solid element, which is what I want. And second order solid elements were created because we used second order shell elements to create it. So that's why it was important to create second order triangles here on the outer surface. Let's click in show all, and it's going to show only the bolt because we had the lock view. Deactivate visualization of node. And the last step is to delete the shell elements that we have around. Because if we go to property, select this property of these shell elements, which is the temp property, we have shell elements with a thickness equals 1, and this adds stiffness to this bolt, right? This shell element is tied to the element, to the solid element. So this adds stiffness to the bolt, which is not correct. So we should delete it. In here, in this list, right click on total shell elements, show only. And before we do that, click on show all. I forgot that I need to detach these shell elements to the solid element so that I can delete it. To do this, go to volume mesh module, release function again, select everything here, mesomorph button, and now we can delete the shell elements after disconnecting the shell elements from the solid elements by using the release function. Right click in shell, show only, delete function, create a box selection, mesomorph button, and we can delete released nodes and released properties. Click on OK. Now click in show all, and now we have only the created solid elements, second order tetrahedrons with curved outer surfaces. Everything is looking perfect. The quality is pretty good. Okay, if we go to the element in the database, so you see that we have these new items, solid, double click here, select one of these, and then select from this list. And then in here, you see that we have C3D10, 10 because we have 10 nodes. Here we have the ID of the nodes. And yep, that's it. Now unlock this view, click in show all, and this is what we have so far. This is starting to look good, right? In the next video, we're going to create the nut, start defining contact, using the same strategy that we have used before, and many other things that we need to do. We need to apply bolt pretension, and etc. All right, guys, I hope you liked this video. We could learn many new things, important things. I know that this is a lot of information, right? But you're going to see that you're going to have to use these tools frequently if you get to work with FEA. So you're going to get used to it. You're going to memorize all these tools over time. Okay. Anyways, see you in the next video.